Hi, this is Mr. Mix. So I have another question here, part two or question two on my series on the applications of differentiation. So I have here a diagram, which as you can see, I've got point S here, which is the coordinate 0, 12. Point T here, the coordinate 16, 0. Q is x, y. R is on the y-axis and P is on the x-axis. Okay, and then this here OPQR is a rectangle. So you're supposed to show that the area of the rectangle, okay, is given by this formula. So basically, you have got many ways that you can do this. Okay, one of the things I like to look at is I like to look at triangle. Let's say OST triangle. OST, the big one, and we'll say it is similar to triangle RSQ. And if that is the case, then OS upon RS should equal to OT over RQ, because there's some similarities there. Okay, all right. So what is it that also that we know from this? Well, we know that the distance from O to R, this distance here has to be Y. Okay, because this point here is point Y, and this has to be the distance X. Okay, so O to S will be O to S, the whole distance from, the whole distance from here, it will be 12 units. Okay, so you can see by that. And then also the distance from here all the way up to T will be 16 units. So O to S will be 12, and R to S will be 12 minus Y. Go ahead and put them in brackets, okay? And O to T is 16, and ORQ then, okay, as I have RQ, which is the same distance as OP, well, that is nothing but X. Okay, so I hope that you can see the way that I have made that. Okay, so in any case, this is now where you see we need to be able to write y in terms of x, because we are looking for the area of this rectangle. And the area of the rectangle is you're supposed to multiply y times x. So here when you do your little bit of cross multiplication, if you so want to speak, you can perhaps get 16 in brackets. 12 minus y is equal to, okay, 12x. So the objective is to make y the subject of the formula. So you can go ahead and say 12 minus y is equal to 12x upon 16. Okay, just maybe want to make that a little bit clearer. So that's 12 minus y is equal to, well, 5 over 8. Okay, let me just correct it a bit. So if you look at your formula, that is 6. It's actually 3/4 of x if you simplify. Right, so the value of y, well, that minus, you can just swap it around, so y therefore will be 12 minus 3/4 of x. So now that we have our value of y, we can actually use that value of y in order for us to calculate the rectangle. So that's going to be y times x, the area of the rectangle. Okay, and once we do that, we should arrive at this 12x minus 3/4 of x squared. Okay, so the area of the rectangle, really, as you have the rectangle there, as you have seen, well, this is really a horrible one. Let's just go ahead and just bring it in here. So we now know that the area of the rectangle is x, which we know, and our y is now being replaced by this distance here. Okay, so our y is 12 minus 3/4 of x. So in order for us to calculate the area, we just multiply that. Okay, so that will be x, 12 minus 3/4 of x. Okay, and we have that, but we want to distribute that x over. So the area of the rectangle is nothing but 12x minus 3/4 x squared. And surely this was what we were required to prove or to show. 12x minus 3/4 of x squared, as you can see there. Okay, so now we have the area of the rectangle. So there's a second part now. It says that x can vary. Find the stationary value of a and determine its nature. Right, so this is two parts to this question. That is why I highlighted the end. So when we have, let me just bring my area here, 12x minus 3/4 of x squared. So in order for x to vary, we differentiate a with respect to x, okay, and we let that equal to 0 because we are talking about stationary value, okay. Now, once you find this particular value here, in fact, the way I wrote it, um, just so that maybe I can correct it, just make some mathematical sense. The moment I take the derivative, okay, I use that, so it will be 12. The derivative of 12x is 12 minus, well, you have got 2 times 3/4, which just gives you 3 over 2. So minus 3 over 2x. Okay, so I hope that you have that part. And from here on, we need to be able to solve for the derivative, or we need to be able to solve for the value of x. And once we have the value of x, we are going to substitute that value of x in our area in order to find the value of a, the area. Okay, so once you do that, this is going to give you minus 3/2 of x is equal to negative 12. You can go ahead and drop the negatives. Okay, so it's basically 3x is equal to 2 times 12, right? And then x will equal to is 24 divided by 3. So our value of x is equal to 8. Now that we know what the value of x is equal to, we're going to go ahead and substitute that value of x into our equation in order for us to find the area. So it's 12. That's 8 minus 3/4 of 8 squared. So our area, okay, just to make sure that what our units are in, well, it's a Cartesian coordinate system, so we're just going to have whatever our answer is, we're going to have that answer squared. So you can go ahead and bring up your calculator in order for you to determine. So it will be 12 times 8 minus 3/4 of 8 squared. 8 squared is 65. Let me just maybe go back there, that in bracket. Okay, right. So our area, therefore, is going to be 48 square units. Right. So then the next part of that question wants us to determine the nature of the turning point. In order for us to define the nature of the turning point, we have to determine whether it's a maximum or a minimum. So I hope you still remember that if you do your second derivative squared, and the value you get, if that value is less than 0, then it's a maximum value. If also, however, you do your second derivative, the square a of the x squared, and your answer that you get is greater than 0, it's a positive number. So if this answer is greater than 0, then we are dealing with nothing but with a minimum value. So I hope you understand that. So what we need to do is we need to find the second derivative. Okay, so we know the first derivative is 12. I'm just going to write it down here. dA dx, that is 12 minus 3/2 of x. Okay, so we need to be able to determine what will our second derivative be. So our second derivative, well, the derivative of constant is just going to be constant. So this value is negative 3, which is less than 0. So therefore, our area is nothing but a maximum value. Okay, so that is the part that we were supposed to determine. And when you are supposed to determine that, you are supposed to do the second derivative. Okay, so just make sure that you run the question again, and then you understand that we always need to write something in terms, this y in terms of x in order for us to find the area. And once we have done that, we can find the area of a rectangle, which is very straightforward. Okay, and we use that y value, substitute in, find the area of the rectangle. We got to where we need to be, and the moment you have got given that x can vary, find the stationary value, you need to differentiate a with respect to x, and then let that equal to 0, because we're saying stationary value. And then to determine the nature, we need to do the second derivative and determine whether it's a maximum area or a minimum area. But in this case, you saw that it's a maximum area.